Hello. So I think for all of you, this is probably the first time you're doing exam, right? Your midterm, Form 4. Never exam before. So I suppose you are not clear with format. Right. You're not clear with the format and everything. Okay, there's one thing I want to explain thoroughly is because now first, of course we're gonna focus more onto chapter 2 lah, to be honest, because now regardless your exam chapter 3 coming out or not, here's one thing. You probably heard of your teacher told you before, right? There's something called essay for your paper 2. Not sure what to do. And then the problem about essay is that the marks is a lot. 1 questions, 10 marks. So you need to know exactly how it works for the format. Now, format very important because some teacher are very strict one. Okay, when I say strict means what? If you write the format wrongly, 0 marks. Now actually got marks one. If you say the proper way of marking, right? Actually they give you marks, just that they minus a bit now. But some teachers are very strict because they want to train you to do the correct way, man. That's why she will give you 0 for sure. So to prevent this is something you want to pay attention to. So this is the main focus today. We will do questions, of course. We will do more questions, the more the merrier. But most importantly, right, I need you to understand the format of the essay. Okay. Now let me tell you what to do with the notes you're having first. Let's see. This one. Let me tell you what to do with the notes. Okay. Teacher said just do graph. Meaning what? Oh no. Essay, right? They will you're supposed to answer in table form. Yep. No, not exact. I mean, the name a bit misleading. I get it because people say, "Hey, I thought essay is supposed to do like a paragraph form. You're supposed to write like an essay, like English essay, right?" No, it's not. Actually, we answer essay in table format. But I want to tell you one thing. In the notes, right, you will see I prepared the table form for you. Like that. I prepared a table for you, right? Exam don't have one. You draw yourself one. You basically be getting a state paper. Full scale paper. So you have to draw this yourself. But I don't want you to waste time drawing the table. That's why I put it for you. Okay. But I teach you what to do with this one first, Your note's supposed to look something like this. But I want to say one thing is first thing first. You look at your notes right here. Okay. You look at your notes at the corner there. It says 2025, right? It says 2025, right? Because I forgot to change it. It's a typo. I mean, it's like that one. Every year, beginning of the year, right? You are so used to writing the previous year. You forget to change it. Same thing here. But no worries. The notes you're getting is the latest one. Okay, it's supposed to be 2026. Just that, this one I forgot to change. It's a typo. Now over here, what you have, right, on the very first few pages, you probably notice, right, I prepared like a short notes for you. Okay, now this is not like notes. What happened is that for this thing, right, because a lot of people, right, you say, I want to study, but I'm not sure what to study, how, right? Okay, so the thing is, I give you a checklist. Because one thing I noticed, a lot of people, you say, I go study one, all right? But the problem is I'm scared. I'm not sure, right? What should I write? What should I not write? Okay, I'll tell you one simple thing. Common mistake, everybody have this one. You don't know what you don't know. So the idea very simple. I give you this checklist, right? What you do, okay? Later on, you go through this checklist yourself. You go through this thing, all right? One by one, you see which part of it, right? Looks like a rocket science to you, like you never seen before. That is the part that you want to put more effort inside. You want to study more. Okay, so this is to clear off all this confusion and all this misunderstanding. So the notes you're getting now, seminar part is focused on chapter 2. For one reason, because now your exam for this term supposed to be chapter 1 and chapter 2, yes. Some of you until chapter 3, yes. But is it like the whole chapter 3? I don't think so, right? Some of you tell me 3.1, some of you until 3.2, right? Some of you until 3.3. Well, the thing is what? Chapter 3 is not the main concern, because you see, if your exam until 3.1 only, right? Practically means not too many things can ask you, Especially one thing is what? Essay. Now, chapter 3 only 3.3, the satellite part got essay. So if you say your exam is not until chapter 3.3, until 3.2 only, until 3.1 only, right? Then chapter 3 got no essay one. That being said, right, your essay comes from where? Come from here. Okay, chapter 2. Now, what do they ask? What topic should I put more effort? Should I put more attention in? Now, I tell you one thing, chapter 2, I'm not asking you to study just these 2 topics, I'm saying that these 2 topics, Okay, these two topics most likely to be your essay questions. Number one, momentum. Do you recall learning something like that before? You know, all the elastic collisions, inelastic collision explosions. Now this one, essay. Later I can do one. Now second thing is impulse and impulsive force. This one also possible to be essay. These two topics, very famous, come out every single time. Okay, so that's why you see I put in the detailed notes and then everything you're supposed to know inside for you. You get me right? There you go. So the notes you're getting, you see, after that, you have start having questions. These are all the chapter 2 questions, okay? But then I tell you what to do first. This one, scroll. These are the things that we are doing in seminar. Not going to be every single question, of course. But as you keep scrolling, right, you will come to a point where it says this, okay? You will see a title says midterm exam revision question. Now, this is an extra one I do for you because a lot of time people tell me that I wanted to study, but then, right, I read textbook, right, not good one. I tell you one thing, guys, exam revision, never read textbook. Yes, you reading, no point one. You know what's the one thing about you want to improve your result? Stop reading, start doing. Exactly, because you see, when you read textbook, yes, you will understand the topic, you're going to understand the concept, but you don't know how they will test you. You don't know how the question will come out, how they ask you. So practice more is more important. Now here, all these extra questions, right, I put in every chapters that you need for exam. Okay, all these answer, right? Now chapter 1 inside got, chapter 2 inside also got, chapter 3 inside also got. So this is a complete version already. You got seminar, and then this one extra for you is your revision notes. You finish this whole thing, you are done for, you are prepared for exam. Okay, now I cannot guarantee inside the question come out exactly same as an exam, but I can guarantee one thing is that the question inside will definitely better than you reading a textbook. That's one thing. Okay, now answer will be posted, don't worry. If you are my students, right, I posted in GC already. Yeah, and then if you are new students, I mean if you are just joining for this seminar, where you find this link is where you find the answer as well. Where you find the PDF file is where you find the answer as well. I haven't posted yet, but after this I will post one. Okay, don't worry about it. Got answer. Relax. Every question, of course, got answer. So here's one thing. Two things I want you to pay attention to regarding essay. Number one is momentum. Okay. Number one is momentum. Yeah. So what happened is like this. First thing first, momentum, right? Of course, they don't just ask momentum lah. Why got so simple, right? Usually when they ask you momentum in exam, right, they ask about this one here. You know, the conservation of momentum. Conservation of momentum. Your total momentum remain constant. Always the same one. Now that being said, right, you will come to this part here where you have the 3 different types of collisions. People always confuse one. I get asked this a lot. You will ask like, hey, I thought it's elastic. How come the answer say explosion one? You know what happened? People confuse between these two a lot. Am I right? You cannot differentiate which one is which because you feel like, hey, elastic and explosion, right, very similar though. Tell you one thing. You see, the difference is what? Elastic collisions, right? It's that you get 2 objects and then they collide. After they collide, right, you know what's the meaning of the word elastic, right? It's like bouncy, like you know, basketball elastic, right? So 2 balls collide, then what happens next? They will start bouncing away, They're gonna go this way and they're gonna go this way, right? This one we call elastic. Now, you know what it means by inelastic, right? Inelastic means when they collide already, they don't bounce away one. Meaning that after collisions, you will see 2 of them stick together. Now this one very obvious one because you will start seeing words like they say they combine together, they move together, they stick together. The word together, that means inelastic because you will be moving. And then one thing about this is that every time when you have inelastic collision, what happens next? You're going to see something like this. They will ask you to calculate something called common velocity. Now, why is it called common velocity? When 2 persons moving together, what is it going to happen? They move same speed, right? That's why you got common velocity, same speed all the way. That's why the formula, you see, there's no V1, V2 anymore. For inelastic, right, there's only 1V. But if you multiply this inside, you end up having what? M1V, M2V, right? Same thing anyway. So ultimately, right, all these formulas, explosion, inelastic, right, they all come from the elastic formulas. Get it right? And the formula for elastic actually come from this theory here. Total momentum remain constant. That's why every time you see before and then after, and then we put an equal in between. Okay, U means initial velocity, V means final velocity. So here, before and after. The logic of momentum, okay, the logic of your conservation of momentum. The idea, if you want to put it in the layman term, there you go. Before, after, same. That's it. Now, explosion. Explosion, a lot of people misunderstood because why? They start telling me that, isn't an explosion like kaboom? And then, must have something explode one. It's actually not true. Explosion is like this. Initially, you got 2 persons, and then, right, they don't move one. The main thing about explosion is that initially, nobody moves. After that, explode, and then what happens next? They're gonna bounce away. They're gonna separate. So this is why you confuse, because if you look at this part here, very similar, right? Elastic also bounce away. Explosion also bounce away, right? So the main thing, I tell you what, every time when you decide which collision to use, you want to decide whether is it explosion, whether is it inelastic, whether is it elastic, right? Now, I teach you the sequence. Number one, always start by thinking this one first. Yep, can I use explosion? And how do I know it's explosion? Very simple. Explosion, right? Your initial velocity must be 0. Now, when I say initial, I mean both, Now, initially, nobody move. If let's say one person not moving and the other one is moving, that one is not explosions. Explosion must be totally 0. Nothing move. A and B, 1 and 2, 0. Understand? So initially not moving. After that, explode. They bounce away. Then you got something called explosions. Now, inelastic, the key idea is this one here. After that, if they connect together, they combine together, then we are looking at inelastic collisions. Now, if explosion doesn't work out, inelastic doesn't work out, then only you decide elastic. You can see it this way. Elastic is like the dustbin. It's like a garbage bin, right? I cannot use explosion formula. I cannot use inelastic. Then only I use elastic. So elastic is the last one you actually think about. You get me, right? Now, worst case, you say, oh, this one I understand, but then in exam I don't remember how. I teach you the simplest way. Okay, an easy cheat code. How to know what kind of collision is that when we're doing calculations. Now, here, when they give you calculations, they're supposed to give you a number, right? They need to tell you information, mass, velocity, right? Now, explosions, you will notice one thing. Your question give you very little information. Why? Because you see in front 0 already. So practically, how many information I need to give it to you? I just need to give you 3 info. Because why? Now, I need to give you M1, M2, and then V1. Then they ask you to calculate V2. If not, they can give like M1, V1, M2, ask you to calculate V2. So explosions, you will notice one thing. The questions give you very little information. Now, to be exact, they normally, for explosions, normally, right, they tend to give you 3 informations only. 3, that's it. Next, what about inelastic? Inelastic, right, they will give you 4 informations. 1, 2, 3, 4. Then they ask you to calculate this one. Elastic will be the most. So if you do notice the question give you a lot of information, that's elastic. If you notice the question give you very little information, that one will be explosions. Get it? Okay. Now next one, right, you see, after that we got applications, because exam is not just all about calculations. A lot of people misunderstood, feel like, hey, isn't it physics just maths? Now, it's half one. Got calculations, of course got theory. They're gonna ask you explain this, explain that, explain why, right? Okay, I'll tell you one thing. One thing is, for applications, right? Now, I'm not saying explosions surely come up. But the thing is, I'm telling you this, explosions, right? It happens more often, because why? Among 3 collisions here, elastic, inelastic, explosions, only explosion actually has applications. Now, all this rocket, all this jet engine, right? They all work under explosion. So you get it? So sometimes they can do it this way also. Top part of the questions ask you calculate elastic or inelastic, and then the bottom part they ask you explain about explosion. Also possible. But here's the thing. Application wise, only explosions. And then I teach you one more thing. You see, next thing people say, oh, this one, all this theory, am I supposed to memorize them? Am I supposed to memorize them? Am I supposed to memorize them? No need. I tell you what, I give you a format. Okay? Every time you answer this way. Especially when we say explosion. Now, the famous explosion application, we have what? The rocket, the jet engine, the gun firing, and then the squid, spray ink and run away, right? I tell you what, whatever it is, right? As long as explosion questions, they have a fixed format one. Now, you study smart. If you memorize one by one, of course, we all know, right? Our brain size very small one. Cannot install everything. So what you do very simple. When you study, right? 2 simple tricks for you. Number 1, look for something that is common. Okay, look for similarities, because when you study one, equals to study everything, because they are same. Second, look for differences. If you study A, you terbalik, become answer for B. You get what I mean, right? Okay, good. Now, let's see. Rocket under explosions, right? Now, have you seen rocket launching before? How do you explain rocket launching? Right now, step 1, what do they do? Initially, rocket moving or not? Before you start the engine, before you light up the rocket? No, right? That's why I say under explosions, initially, nobody move. Next thing, what they do? Then you start seeing a lot of smoke, fire, flame coming out, right? Now, don't say smoke and fire, no marks one. The thing that comes out from this one here, after burning, after combustions, whatever we produce, we call them exhaust gas. So rocket, simple. Step 1, You mix up the fuel and air, always, right? You want combustions. What do you need? 3. You know what's the triangle of combustions, right? Fuel, heat, oxygen. So the fuel mixed with air, combustion starts. And then you tell them explosion occurs. Now, over here, right, when we say explosion occurs, does not mean like kaboom explosions. No. You're telling them rocket uses explosion, as in like your collision type. Now, example, let's say the question is about elastic collision. Then answer here, you write elastic collision occurs. You got me, right? Inelastic collision occurs. Explosion occurs. So this meaning of the word explosion here does not mean like, you translate explode, bam. No. Explosion is telling them your collision type. I know rocket uses explosion as collision type. After explode, what happened? You start producing a lot of exhaust gas, flames, smoke, everything together, right? Now, all this flame and smoke, what happened? They start to spray down here, right? Now, that is when I teach you a simple trick. Can you tell me formula for explosions? 0 equals what? M1V1 plus M2V2. Now, let's do a bit of simple maths here, guys. If I say plus, right, what happens if I bring over? Simple mathematics. This one positive, If I bring it over, what do I get? If I shift over here, yep, I get negative. Good. Now, in physics, what does it mean by this negative? I say many times already. Okay, one thing for those who don't know, one thing very important. Negative in physics is not like maths. Okay? Negative is not like maths. Basically, it's like this. Negative means opposite. Remember this simple sentence is negative means opposite. You get it? So 2 things to pay attention to is number 1, negative, number 2, equal. Okay? So what does it mean by that? Now, your momentum will be the same, value same, but then the direction will be opposite. So here, if the gas come down, what happened to the rocket? Negative, If the gas go down, negative means what? You expect to see the rocket start going up. And then how does it work? They will be equal. So that's the meaning of this formula here that helps you to understand. Okay, exhaust gas produce downward momentum, and then rocket will go up with an equal but opposite momentum. You understand me, right? That's a simple trick here. So minus, equal, put together. So that's why, right, you see when it start burning, what happened? The exhaust gas gonna move downward with a high velocity and then high momentum. This one must mention so. They come out high speed. Why? Because you want a lot of momentum. And then next thing, point number 3, you tell them the principle. This one short sentence will do. You don't have to write the whole thing. I mean, if you want to write the full definition, can also lah. But most importantly, tell them the total momentum always conserve. Always the same, always the conserve. And finally, what happened to the rocket? They will move upwards with an equal but opposite momentum. That's why the meaning of this negative, equal but opposite. Okay? Now, your format of answering is always like that. Okay? First step, you tell them what kind of collisions for rocket? Explosions. Okay? Then this one must mention direction can be different. What? You see, for rocket, yes, the gas go down, right? Let me ask you a question. What about this one here? Jet engine for airplane one. What happened to the direction of your rocket? Where do we go now? What happened to the direction of the exhaust gas? For jet engine, right? Where do you get the exhaust gas? Is it going down? Airplane, no, right? Airplane, how it works? You want them to move forward, so that's when you start having a lot of smoke coming out from the back. Right, so why you must mention direction? Because every time this one can change. Can be downward, can be upward, can be backwards, can be forward. Okay, you follow lah, So they come down downwards, and then after that, remember to talk about this. High speed means you have high momentum. How come? Because momentum formula, the basic one, momentum equals to mass multiply velocity. So if your velocity increases, what happened to the momentum? They're supposed to increase together. Understand what I mean, right? Finally, tell them, typical, throw in your principle definition. The short one will do. Total momentum always conserve because it's called principle of conservation of momentum. And then finally, tell them directions. If your exhaust gas go down, your rocket goes up. If your exhaust gas go back, your rocket, whatever, will go forward. Always, why is it the valid one? Equal but opposite momentum. Now, this one is the format for any explosion questions. Every time, right, what do you do? Step 1, you tell them what kind of collision happens, right? Explosions. Second thing, you get exhaust gas. Not necessarily exhaust gas, actually. Can be any other thing also. But most importantly is what? Whenever they are released, whenever they come out, right, they always come out with high velocity. Now, why you want high velocity? Because high velocity produces high momentum. And most importantly, one thing, you're supposed to always remember, mentions the directions. Whether you're going forward, whether you're going backwards, Must tell. Next point, what do you say? Then you tell them, you throw in the principle. Okay, principle of conservation of momentum. Conserve means like preserve. Conserve means they are same. So you tell them the principle of conservation of momentum. In layman term, conservation means they are same. Okay, simple as this. Conserve means constant. Conservation means they are the same. And finally, what happened? You will produce an equal but opposite momentum because of the formula. Now, whatever explosion explanations, right, you follow this format to answer them. Whether they ask you rocket, jet engine, whatever. Later, I show you one more example. Then you start seeing the pattern there. You start seeing the similarities there. Then your life are simple. You get me, right? One by one. Explosions, high speed, high momentum, and then throw in the principle, and then equal but opposite. Got it? We try again. Okay, jet engine is for airplane. Have you seen airplane take off before? Let's say this one is airplane. This is your airplane, that is airplane. So how airplane works, by the way? Let's say this is the runway. Have you seen airplane do this before? Like, on the runway, up and then go away. Okay, do they do it this way? Wait, why is it lagging one? Okay, sorry. Now, have you seen airplane launching like that? From here, up, and then after that, go away. Is it like that? What do you normally see? The airplane need to move forward, and then after that, go up, right? You get me or not? So that's the simple trick here. That's why right now, your jet engine, what do you need? If you need the plane to start moving forward, first thing first, what kind of collision are we using? What kind of collision we're using? Correct. Explosion. So again, you see, air mixed with fuel in the combustion chamber. Combustion chamber is a space. Combustion chamber is a space. So that's why we can just, you can just imagine it's a room. So combustion chamber happens, and then explosion occurs. Okay? Explosion occurs. After that, exhaust gas come out, and then they come out with high speed. That means you got high momentum. Make sure you tell them what directions. Can be backwards, can be downwards, can be anything. And then point number 3, principle of conservation of momentum. You tell them the total momentum always conserve, maintain the same. And finally, what happens to the jet engine? They will produce an equal but opposite momentum. Now, if you say backward, then right now become forward. You know what I mean, right? So that's a simple idea. So this is the concept every time when we explain. You see, do you realize it's the same thing again? Over and over again, right? What's the first thing you say? You tell them what kind of collision happens. Second thing, high speed. That's why you got high momentum. And then make sure you tell them what direction are you going. Are you going back? Are you going forward? Are you going downwards? After that, throw in principle, short answers. Tell them always total must be conserved, meaning must be constant. If you don't want to use the word conserve, can use constant as well. And then finally, equal but opposite momentum. And then if you say backward here, it's going to be forward. If you say downward, it's going to be upward. Get it? So right now, you realize, right, no matter what, ultimately, the concept is over here. This is the 4 things I mentioned, right? This is the concept. Now, I say this first, all of you, listen, when I explain to you, right, you follow first. Because one thing about this is that if I stop to answer your questions, right, it's going to be very slow. And ultimately, your question is going to be answered anyway, because whatever you want to ask is always there. And yes, if I did not answer to your questions, then ask me later. Because every time now, here's the thing. When you ask me a question that is not relevant, I know you are not listening well. You are basically just, in your own world, and then you think about all random things that not even important, not even coming out for exam. What is the point? But if I stop to explain this, then you see the problems, right? So this is why one thing, I will answer one by one. Don't worry. I will answer your questions. Okay? I will answer your questions one. Just that you follow first. Yeah, we move on together. Then later on, there will be checkpoint and stopping, Then you ask. If not, right, the progress very slow. Move a bit, stop a bit, move a bit, no point. Okay, and then next thing, you know what happened or not? Some of you will start asking me questions like, hey, question number 2, how to do? Then you're not listening, right? So I will go there, but you let me finish what I want to finish first. And everybody's speed is different. I want to make sure, I want to tune all of you having the same tip. We move on together. Understand? Okay, good. This one, clear. Momentum questions, right? Collision 3 types. And then after that, theory. Follow this format. Answer every question. Now, what if they ask, okay, next thing. You ask, hey, what about the squid? What about the squid? Squid got no burning one, we don't mix fuel with air, right? That one you change, Then you tell them, the squid spray ink out. Okay? And then explosion occurs. Same, right? After that, the squid ink come out with high speed, produces high momentum. According to principle, the squid will move in opposite directions, equal but opposite momentum. See that? So whatever they ask you in the future, try to apply this and your life a lot simpler. Okay? All right, let's try. Everybody, page number 8. Page number 8, okay, follow together, move on together, okay? Now, I teach you a simple trick. Sometimes you say, hey, my copy very slow, how? Take a screenshot, then you can copy slowly, right? So anytime you writing down answers, you are slow copy, whatever, you take a screenshot. Easy, okay? All right, now, diagram 4.1 shows a space vehicle moving with a velocity of 0.5 meter per second. Okay, one simple trick I like to do a lot, especially for this topic. Because if you think about the momentum, you got 3 formulas there, right? And then all the formulas for momentum collisions, right? What is the problem here? You got 2 person inside, right? You got M1, M2, U1, U2, 2 person. Then the problem, normally people, what happen? They tend to mix up. Suppose the value for M1, then you put for M2. Answer wrong. So what I do is, normally this is what I do. When I'm doing practice, whatever, I will prepare 2 color highlighter. So as I read the questions, right, what I do very simple. Okay, like here I got 2 person, I got space vehicle and then I got space probe, 2 person. So space vehicle, I assign a color, and then space probe, I assign a color. So as I read, I colored them with highlighter. I mean, don't color the whole thing, of course. But I don't need to keep reading the sentence again to double confirm. Oh, this one is for vehicle 1. Oh, that's for probe. No need. Okay, space vehicle moving with velocity of 0.5. That's for red color. And then dot to the space probe that is moving in the opposite directions. Okay, opposite directions, right? The mass of the space vehicle, okay, it's 2,500 kg and space probe are 1,005 kg. You know what means by the word respectively or not? Respectively means accordingly. Yes, so they write space vehicle and probe, meaning this is for vehicle and then the second one is for probe accordingly. Okay. After docking procedure, the space vehicle and the space probe move together with a velocity of 0.2 meter per second in the original directions of the space vehicle. Okay, here, when you see this keyword, almost there already, right? First thing first, what does it mean by this? That's why I say very obvious one. Very obvious one. If you see they say move together, combine together, sticks together, correct. What kind of collisions we looking at? Inelastic. We good? Okay, inelastic. Well, here's one thing. If you say you really don't know, what did I teach you? Step 1, what do you do? Ask yourself, can I use explosion here? Explosion, how to know? Very simple. Initially, nobody move. Nobody move. So is it moving? The moment it moves, cannot be explosions. Get it? Then the next question, is it inelastic? Move together, right? Then yes. Okay, if they say after collide, they never dock properly, never combine, they collide and then they bounce away, then elastic. So your sequence always try explosion first, and then inelastic cannot, only elastic. Based on the information provided, calculate total momentum of the systems. Now, you know what means by total momentum, right? The word total means what? Yes, sum them up. But the problem is, did they say this is the total momentum before or after? Because right now you see this is before, this one after. So which one do we calculate? They didn't say though, they say total momentum only. Do you know why? Reason very simple. Again, this principle tells you what? The definition for the principle? Total momentum always conserve. What is the meaning of the word conserve? Conserve means, I said just now, right? Conserve means constants. Conserve means they don't change. Get it? So does it matter which one do I calculate? Can I calculate before? Can I calculate after? Can. Why? Because they are equal to each other. But of course, in this case, which one you want to calculate? Which one is, if you're given information, you decide. What do you think? Before, after? Which one you can actually calculate? Of course, after lah. Why? Before, what is lacking? Something missing though, right? Before that, you don't have this one. Right or not? You got speed for the probe. Cannot calculate lah. Right? But after that, you say, but after that only got one speed also ma. But the thing is what? After that, they are moving same. They are moving together. Meaning what? The 0.2 is for who? For the probe and also the vehicle. Get it? Okay. So now, total momentum, how to calculate? You can choose either one because they are same, no restrictions one. But in this case, since only after provided, I calculate after lah. After momentum, how to calculate? Everybody, guys, remember the formula for inelastic formulas? I get it. Oh, yes. Now I say this again, everybody listen. Don't ask me, formula sheets will give or not. Yes, because I don't know. Every school different, okay? You ask the teacher. Now, only for Form 4 first term, midterm lah. Finals, I can tell you, there will be formula sheets given. SPM, I can tell you, there will be formula sheets given. But first exam, I don't know. Because first exam, the problem is what, you know why? First exam, right, only chapter 1, 2, 3 ma. Then some teacher will feel like, hey, so little chapter tested, no need give formula sheets lah. So some school, right, they don't give one. And some school, they give. Depends on your teacher. Okay, whether she happy or not lah, you decide yourself. Yep. Okay? You ask the teacher, you don't ask me. Every school different, I cannot guarantee. Now, inelastic formula, M1 U1 plus M2 U2 equals what? Yes. No. We don't write. Okay, can I write like this? M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2. Do we do it this way? No, right? Why? We don't have to, for one reason. Because the V is the same. And of course, you learn maths, right? If they are same value, what can you do? Correct. You can factorize them like this. Right. There you go. So this one before, this one after, you decide yourself, lor. And of course, you decided, right? You're supposed to calculate after. So M2, M1, M2, and then V. Multiply together, we get answer. Mass of the first person, you decide yourself, M1, M2. So I assume this one 1 and this one 2 lah. You can change yourself if you don't want to. You happy, you want the probe to be 1 also can, but you follow. So in this case, right, the mass is 2005. Look up the question given one. Okay, M2 is 2005, and then the V is 0.2. Okay, so what's the final answer are we having? 2,500 plus 1,005, and then we multiply by 0.2. What do we get? 2,500 plus 1,005, and then multiply by 0.2. What do you get? Yes, did you get 800? Did you get 800? Correct. Not good. Why? Every time, final answer, we always have what? Unit. Good. What's the unit for momentum? Simple. Whenever you don't remember unit, write form yourself. Whenever you don't remember unit, form yourself. What are you doing? What you did is, you take kilograms, multiply velocity, right? Multiply, very simple, A times B is what? AB, correct. So kg, ms, -1. Okay? Next one. Calculate speed of the space probe before. What does it mean by speed of space probe before? Basically, they want U lah. And then probe is this guy. So basically, looking for U2. This one obviously lah. You're gonna use the inelastic punya formula. Substitute accordingly lah. Okay, you're looking for U2. Right. M1 would be the mass of the vehicle, 2,500, given by the questions. Initial velocity. What's the initial velocity? Cannot put Newton, of course. Newton is unit for force, not momentum. Initial velocity is 0.5. Okay. And then plus M2 is 1,005. U2 is what you're looking for. Right? Equals to, this one don't need calculate already. You know why? You already calculated what? This part here, whole thing, 800. So bring this over. 1,005 U2 equals what? 2,500 multiplied by 0.5. You get 1,250, but if you bring over, what do you get? You're gonna get 800 minus 1,250. Minus them, what do you get? You can just calculate straight away, no need to show working out one here. Yep, you end up having negative 450. Okay, so that means U2, final answer, how much? Divide by 1,005, mass. Did you get 0.3, everybody? Negative, of course. Okay, now guys, what does it mean when I have negative? Physics. Negative means what? Opposite, correct. Now, supposed to negative or not, you see for yourself. Here. The vehicle go here, your probe go here. Opposite directions, right? Somehow they mentioned specifically here, opposite directions, right? So it's correct. Yes, you should get negative answers because the negative shows you opposite. No, actually, okay, here's one thing. People ask like, hey, do I leave my answer like 0.3 to the left, 0.3 to the right? Now, you don't need to use left, right, up, down one. Okay, physics, our direction is very simple. We use positive and negative. Okay? If you only have one directions, all the way positive. But whenever you got two different directions, then you put plus minus. Understand? We good, huh? Next one, state and explain the principle involved. Tell me this, what kind of principle involved in your calculations? Who's the one that tell you M1U1 plus M2U2 is going to be equals to after one? Correct. Okay, principle of conservations of momentum. Now, this is state, Tonima. You want to explain. The meaning of explain meaning what? Definitions you have to write lah. No, you don't learn principle of conservation energy. That one is science, come on. Next thing, the so-called explain principle involved, right? Simple layman term means definitions. Now, what is the definition for principle? This one here. What is it? The total. Okay, this principle tells you what? Total momentum. How? Always reserve. You want to be more explain. You want to explain more lah. What does it mean by more? I mean, what does it mean by total momentum always constant, always preserved? Okay. Here you go. Let me write down the answer for you. Hold on for a second. Total collision before equals to total after, not correct. You need to mention one thing very specifically is you want to tell them that the total momentum is the same. If you just say total collision, it's not correct. The keyword is total momentum. Always conserve. Now you want to use the word constant also can, but we will normally prefer conserve because it's called conservation of momentum. If there is no external force acting on the system, meaning that you don't use any extra thing to collect them. It's like just two of them playing with each other. There's no extra, one more rocket, one more spaceship hit them. You get what I mean, right? That's the point. Definition is always 1 mark 1. Okay, here's one thing. I say this again. Definition, you want to memorize or not, your choice. But I'm telling you, they confirm come out. Okay? Normally, paper 2, 5 marks. Yes. That's why you have this, normally first exam, you have this kind of, realize, you probably will tell me that, the exam question keep asking about definitions. Now, reason very simple. Definition 1 mark. Okay? And then if I say they will at least come out 5 marks means what? 5 questions. So you have this kind of feeling that, the whole paper was asking about definitions. 1 definition, 1 mark. But this one here is state and explain. You tell them the principle, they give you 1 mark. And then you write down the definition, they give 1 mark. So now sometimes they will just straight away ask, what is the meaning of principle of conservation of momentum? Or what is the definition for principle? So definition 1 mark. But this one they ask for the principle involved. That's why I give 1 more mark for you. Okay. Next one. Describe the propulsions of the rocket in terms of momentum. And then you see they specifically mentions about momentum, right? Okay, I get this a lot. People like asking me like, I learned Newton's third law. Okay, Newton's third law also, right? Every time we apply a force, we get an opposite reaction force. Now, can I explain rocket using Newton's third law? Actually, you can, but you won't have enough marks. Right? You can't be so detailed. So usually all these rocket, jet engine, whatever, right? I will always suggest you to explain using momentum. And some of these questions specifically mentioned in terms of momentum. This one, if you use the third law concept, not going to give you any marks. Okay? Propulsion means forward. Basically, explain how rocket works, which I told you just now, am I right? What is the 4 point that we mentioned? Okay, I don't need full sentence yet. You just tell me the point form first. What is the first thing you say? What must you tell? First thing first. What must you tell? First thing. Yes, explosion occurs. Correct. So, how do we start engine? When the air mixed with fuel in the combustion chamber, all right, explosion occurs and produces hot exhaust gas. So, stop saying like, they got flame, they got fire, they got smoke. Now, all the fire, smoke, flame all add up together. Everything that shoots out, we generally call it exhaust gas. Okay? So first point settled. What was the second point to say? I told you just now, you must tell me. High velocity produce what? So the exhaust gas, all right, will exit the nozzle with high velocity, producing a high momentum. Correct. But you must mention what directions, right? For rocket, the exhaust is moving in what directions? Is it up or is it down? Is it left or is it right? Just now is, okay, correct, downward. produces a downward momentum. Okay, because you want the rocket go up, that's why you shoot down. Third point, what do we say? Yep, according to principle of conservation of momentum. What does this momentum says? You don't have to write the whole thing, just the short in front will do lah. The total momentum in the systems will remain constant. You can use the word conserve, constant, equal, or correct. And finally, what happened, guys? Finally, therefore, the rocket will how? What does the rocket do? Exhaust go down, Yes, go up. How come? The rocket will move upward with an equal but opposite momentum. Okay? Now, that's how you answer every time. Questions like that, 4 marks. Now, normally explain questions. Actually, you don't have to ask me how many marks, one. Your exam questions, right, they will put marks there. They will bracket, and then they will tell you how many marks, one. So every time, right, it's a very good habit also to look at the marks given. Then you ask yourself, is my answer worth the marks or not? If they give me 2 marks, I put 2 points inside. If they give 4 marks, I put 4 points inside. So do we have 4 points here? Point number 1 says what? You tell them what happened. Explosion occurs. What kind of collisions? Second thing, you will release high speed. That's why high momentum. Make sure you tell them what is the directions. Is it back? Is it down? Is it forward? After that, throw in the principle. All right, literally short definitions. Total momentum remain constant. And finally, the whatever object will move with opposite directions with an equal but opposite momentum. So you see, the marks was given this way, 1 mark, 2, 3, and 4. Okay, here's one thing. Do I expect you to be exactly same in exam? Of course, no. This is the thing that, some people always fear like, hey, but my teacher, right, very strict one. No, every time I answer, she say, not in marking schemes. Now, whenever she say your answer is not in marking scheme, what does it mean by that? Like for real, they want you to copy bulat same as the marking scheme, How can it be? How can anyone have the same answer as marking schemes? What she wants are the word I highlight. You need to understand, this is physics, not English. They don't care about your grammar. So I don't need you to use all the atas English word one. Normal sentence will do. Get it? Now, next thing people ask, can I answer my answer in point form? I say this one last time. I do not recommend. Yes, to be honest, SPM, they accept you writing point form. Means you literally just write all the word I highlight. That's it. You don't even need connectors, what, therefore, first of all, no need. Right? They actually give you marks for SPM. But school paper, right, some teachers are more strict. That's why I recommend always everybody, best for you to just write everything. And also, it's a good habit, You need to learn how to express yourself. In how? Everything in point form. You go to college, how? Everything point form. The report, your lecturer gonna throw them in the garbage bin, So full sentence, okay? Short sentence, straightforward, clean sentence will do. Are we good? All right. So far so good, Can. Let me know when you're done so I can move on. I want to talk about the essay. I want to teach you the format for essay. Okay, let me know when you're done. So far good, everybody? Okay. Afternoon slow a bit, I understand now. Because you finished lunch already, right? Now still okay one. I mean, almost there. Food coma will come and then everything becomes slow and tired, right? All right, now, next one, move on. Food coma already came good. It will pass in 15 minutes. If not, you can stand up. You just stand and look at the look at the video. You don't have to sit there. But the more comfortable you are, the easier for you to fall asleep. Yes, so don't lie down on the bed there. Some of you probably on bed, on your mattress, right? Getting comfortable, look at my video, right? Okay, here, guys. Here. Essay. Now, important, Listen carefully first, Essay got 2 types. Okay? In case you don't know, your exam, paper 2. 3 sections. Section A, Section B, Section C. Okay, Paper 1 is objective, All objective, no sections one. 40 questions, every question 1 mark. Okay, paper 1, very easy one. 40 question MCQ, that's it. Choose ABC, that's it. Okay, Now, paper 2, it will be like this. Section A, B, and C. Yeah. Section A, 8 questions. Okay. Section A, 60 marks. And then 8 questions. Every question must do. Compulsory. Must do. structural questions. And then the so-called essay will be over here. Section B and C, both. Section B, 20 marks. Section C, 20 marks. Now, SPM format. By right section B, you get question 9 and question 10. Section C, 11. By right like this. But then, right, most of the time from 4 midterm, here, don't have 9 or 10. Yes, because normally it's like this. They give you 2 questions, you choose one. You choose whichever you can do. But then, since this time only chapter 1, 2, 3, I don't think they will let you choose lah. So likely what will happen in your paper is that they will modify a bit. You will get question 9 here and then question 10 here. Yes, so practically you have to do 10 questions. Question 9 here, question 10 here. Now, why are they different sections? Right? I tell you what, section B and C are different format one. Section B for me, I like to call this as the side essay. Got essay, right? But it's different type. Okay, section B is called the side essay. Whereas for section C, right, it's called design essay. Yep. Now, what's the difference? How to tell which one is which? Of course, you say, hey, they will tell me or not, this is design or decide. Very simple one. You look at the questions, okay? Now here, this one here belongs to design questions. Why? Because you notice or not, they give you the condition. I need to design a rocket. I need to make sure the rocket can fly very far away. And then they give you some point, some hint. Or you maybe want to suggest your modification based on the following aspect. Now this one there, it's basically what we know as the design essay. Okay, it's come out in section C1. You have to write everything yourself. Okay, no, I mean there's hint, but that's it. Design. Yeah. Now design, right? The marks given how? Design and decide both essay lah, 10 marks. But the way different if it's for design, the marks given to you would be 8 plus 2. Sorry, design is 5 times 2. Later I explain to you why. Basically means you write 5 points, every point worth 2 marks, multiply 2, that's why the 10. Whereas for decide, right, it's going to be 8 plus 2 1. But you see, no matter what, the marks given together, how much? 8 plus 2, how much? 10. 5 times 2, how much? 10. Then of course you say, do you have an example for decide? Nah, I'll show you one more. You look here, we'll do look here. Say this. You require to study specification for jet engine. Okay, and then you notice what happened here? They will give you a table. And then they ask you, choose the most suitable design. Determine most suitable design. This one, I will call it as a decide essay. Why? Because literally, you are deciding, right? You choose which one is the best. So essay got 2 types. The way you answer different one. I will teach you both. You listen carefully. Okay, design, everything you write yourself on. Okay, whereas for decide, you get to choose. You want big or small, they let you choose. Okay, now let's try the hard one first lah. Okay, over here, this one here is they told you your situations here, you have a water rocket. You are required to give some suggestions to modify the water rocket. Okay, and then what's the requirement? You need this water rocket to travel maximum horizontal distance. Okay, guys. You know what it means by this word? Do you know the meaning of the word horizontal? Horizontal means like this. Because you're wondering, I thought rocket go up one. Like that is called vertical. Like this is horizontal. So this rocket is not they don't want to fly high. They want to fly far away. So you know what you do or not? You don't launch the rocket this way. Instead, what they do some school actually got this kind of competitions, right? Water rocket. From time to time, I guess students asking me, teacher, my school got these competitions, right? I need to design water rocket. How? Now here, normally, with supposedly rocket like this, you put them straight up, and then they just shoot up all the way, right? From here, up, right? But right now, you know what happened or not? If you want horizontal distance, right, they will put the rocket this way. Slanted one, slanted one. So that when your rocket gonna shoot up, meanwhile, forward, fly all the way, and then like that. So what you want is the rocket to do this. Get it? Okay? Right. Now here, these are the hint for you. You need to design the rocket based on the following point. Material, shape of the rocket, angle of launching, volume of the rocket, and then additional feature. Okay, now, recently your SPM style is like this. Now, last time, right, 5 points, right? 5 times 2. Last time, right, they be very kind to you. They give you every point. You just follow and answer only. One by one follow answers. But then after that, right, people complain. People say like, hey, not that I never study, but the point I study, right, you never come up, so I cannot write inside. Okay, so right now, you know what they do? Nowadays, right, the basic trend is always like that. They will give you like 1, 2, 3, 4, or maybe sometimes just 3, either 3 or 4 only. They won't give all 5. But listen, you want to get 10 marks in your essay, and yes, question this one confirm 10 marks one. You want to get 10 marks, you must give me 5 points, and then times 2. You understand? So you say like, hey, if they're gonna give me 4, then how? Then that means 1 more point you have to freestyle, lor. Like, you know, you see the 5th point here? They didn't say anything, right? Additional structure. Others. So this one means you can freestyle. Now, of course, you cannot really say, oh, then do I write anything? Of course, something relevant. But no matter what, 5 points must write. You cannot say, they only give me 3 points. Do I put 3? They only give me like 4 points. Do I put 4? No. They give 3. You answer the 3 already. Make up another 2 more for yourself, from yourself. They give you 4, right? Create another point for yourself. Understand? Okay, good. Now, one by one, later we go through answers. Now, first thing we discuss first, material used. Okay, this one important, guys. Every time, listen, this one important. Whenever they ask, let's say for design essay, every time when they ask for material, right, one thing very important is what? Never tell what material. Yes, because a lot of time people say like, hey, they want material. Isn't it supposed to say like, I want copper, I want metal, I want plastic, I want rubber. Now, remember this, whenever they ask for material, never tell them what exactly material you want. Because there's always better choice one. Yes. Instead, what do? Describe its property. Why do you want copper? Why do you want this? Because I want something that's hard. I want something that's strong. I want something that's lightweight. Then these are your answer. So don't say, I want copper. Say what? I want something hard. I want something heavy. I want something lightweight. You get it? Now, by the way, have you seen water rocket before? Anybody know what kind of material we use for this thing? What material? No, you tell me what material first. No need property. What material first? Plastic. Why they use plastic? Then you think one more step. How come of so many material, why plastic? Correct. Plastic is lightweight. But one more thing. Physics. You know what? I teach you this word. Instead of saying lightweight, what is another better word to use? You want to say always this one for all material. Every time you want to say that I want something lightweight, you say low density. Okay? Now, physics, we always like using this word one. Do you recall some learning this before? Do you know what is density or not? Density. The unit for density is kg m-3. How do you pronounce this thing? Kilogram per meter cube. Now, this one is based on material itself. Every material different. Let's say, for example, density for water is 1000. Density for oil is 800. That's why oil floats on water, because it's lighter. So one simple thing. You want something lighter, say low density. If you want something heavy, choose high density. Get it? So don't say, I want lightweight. I want low mass material. No. You know why or not? Because the lightweight is your explanations. So when you put in front your point, right, you can't explain yourself later. So one simple trick for you, learn, use this word. Yes, in the future, you're going to be benefit from this anyway. Okay? Every time, whatever questions, whatever topic they ask, right, if you want something heavy, high density. If you want something light, low density. Get it? Okay? So what do you want? Do you want a high density or do you want a low density? Obviously, we wanted a low density. Why? Because you want it to be lighter so that they can fly further and also faster. We good? Next one, shape of the rocket. How? What shape? This one need to be science one. This one need to be science a bit. Yes. What do you think? Shape of the rocket. You cannot tell me like, triangle, pointy, whatever. This one, the name very specific one. Okay. Have you heard of this thing called aerodynamic? Yes? No? Now you learn. These are the words we use. Now, do you notice, right? All the rocket, it's always pointy one like that. And then airplane, the head is always pointy one, right? That shape is called aerodynamic. Yes. Now, have you heard of this word before? Streamline. Have you heard of the word streamline before? No also, right? Now you learn, no? Okay, I tell you what, streamline, aerodynamic is the same. Exactly same. Yes. So you probably ask, hey, does it mean I can use either one? Nah, listen, in school exam, I mean, not just only school exam, in SPM also, yes, they are same shape, but usually how we differentiate them, if you want to reduce air frictions, you want to reduce air resistance, then use this, because aerodynamic for air. Okay, streamline for what? For water. If you want to reduce water frictions, water resistance, then we call them streamline. Like for example, if you're trying to design like submarine or a ship, a boat, you want it to go faster on, then you say the shape of the boat should be streamlined. Okay, but let's say I want to design an airplane, a rocket, a sports car, a train, okay, that you don't put inside water right now, then you say aerodynamic. But I don't want you to get confused. You say, hey, what is the difference between them? Actually, no difference. The only difference is what? Aerodynamic for air, streamline for water. Simple. Okay, but of course, in this case, what do we choose? This is water. No. Water rocket is not in the water one. Hello, water rocket is you put water inside. But this thing fly where? Surrounding is air. So which one do you choose? Correct. Streamline. Aerodynamic. Aerodynamic is to reduce the air frictions. So you go faster. Next one, angle of launching. Remember I said, right, we don't shoot it straight up, because the question wanted horizontal distance. How do you launch a rocket? I said just now. How do we launch a rocket? You must launch it at an angle, right? Now they're asking you, what is the angle that you want to launch it? Okay, now here. Simple, you guess. 45 degree, correct. 45 degree. Now, why 45? Because 45 is like just half, right? Perfectly half, right? You put like this is 90, so half of it is 45. And you know why 45 is good or not? Because it's half. Yes, half of your force will use to go up to send the rocket up, and then the other half is to send the other half, right, is to send the rocket forward. So what happens if you do it 45 degree? Your rocket gonna do this, like this. Okay. Of course, can I use other angle? Okay, let's say what if, right, 60 degree? What if right now, right? Okay, this one is angle, so 45 degree like this. What if I use 60 degree? 60 degree means something bigger, you know. So what do you expect to see is that your rocket, now, if you do 60 degree, your rocket be like this, right? It will be more like upwards, more to the vertical side, less to the horizontal side, right? You know what happens if you do 60 degree or not? Your rocket they will fly very high, but then they will and then choop, like that. This one will be 60 degrees. Is it good? Well, if the question do ask, I want to fly high, I want the maximum vertical distance, then choose the angle bigger. But 60 is not best, 90 is the best for vertical distance. But you notice, right, the problem is your force is used to go up already, so less of it go forward. That's why they be like this. Of course, you ask, hey, then if that's the case, right, shouldn't I put like lesser angle? Now, okay, let's say I 30 degrees, let's say now the rocket like this. Isn't it good? 30 degrees. You know what happened? Now I got more force used to move forward, right? But you know the problem is what? Your rocket will be very low. And then the problem is due to gravity, they get pulled down. You know what happens if the rocket do this? They will be like, yes, fly forward very fast one, but then the thing chop, they will land the ground very fast also. They be like this. Once they touch the ground, they will stop already, right? Because your ground is going to be having a lot of frictions. So that's the difference between 60, 45, and then 30. Understand now? So of course, which one is the best angle? 45 is the best because they give you the maximum distance. Yeah, I draw for you to see but exam of course no need to draw I show you only so that you understand better, right? That's the difference between 45 degree and 60 degrees. Pretty good. So angle launching 45. Later I give you answer, don't worry. Next one, volume of water in the rocket. This one, of course, no need to be specific value. It's more like a percentage, or maybe you can tell me fractions. Now, whole bottle, do you put the entire bottle water? Like, do I put water all the way? Okay, first thing, this thing is going to be like rocket, ma. You're supposed to have something shoots downwards, right? But instead of having exhaust gas coming down, what's that? You get water coming down, right now. But the thing is, do water just come out itself? Do the water just gush out itself? No, right? You're supposed to pump air inside. Yes, and then the pressurized air inside pushes the water out. But let me ask you a question. If I put whole full bottle of water, little bit space for the air, do you think the air enough to push the water or not? And you know what's the downside when you have a lot of water inside? It will be very heavy. Yes. So what's the volume to put inside here? Fractions. How many? Like, 1/4, 1/3, 1/2, 1/5. Actually, the answer, they accept 2. Sometimes I notice one thing, marking scheme, they accept 2 answers. If you tell me half is correct, but actually, this is a bit off syllabus, based on calculations, if you really go and calculate properly, right, the volume of the water, the most optimum one supposed to be 1/3. Yes, 1/3 as in what? 1/3 water, and then 2/3 is air. Yes, you know why? Number one, you want this thing to fly higher, it means it has to be lightweight. Second thing is, you need to understand, air is a lot lighter compared to water. So you want air to push water out, you must have a lot of air. The ratio is not 1:1. So if you say half, the air is not enough to push water out with high speed. So usually what we do, right, we have 1/3 of water, and then 2/3 I put gas. I pump, and then it shoots out. But if you say 1/2 also correct. 1/4, 2 liter already, the water will finish very fast. So the best, the most perfect ratio, 1/3 of water, 2/3 of air. And then finally, what is the extra additional feature I need to put? Rocket, I give you a hint. I need this rocket to fly very stable one. Like, they can fly straight all the way. Okay, like here, you look at my camera. Imagine this is rocket. Imagine this is a rocket. Okay, so if your rocket is like botak like this, okay, like that only, you know what happens if you launch it? They don't go up straight on, they will start wobbling like that. Now imagine rocket like that. If you launch it, right, without, it's like, imagine just one tube shape like that, your rocket will do this. Fly everywhere and then go the other side. You need something for balancing one. This thing, that thingy, right? This thing, right? Okay, this one, we have a name for it. We call them wings. No, not supposed to call them wings to be exact. You're supposed to call them fins. Wings is like airplane, then we call them wings. This thing is called fin. Yes, how many fins? Normally, as long as you can perfectly divide okay, this is your rocket, as long as you can perfectly divide and put them right, then should be okay. But usually we put 4 because it comes in pair. So like that, you see 1 here, 1 here, 1 here, 1 here, 1 here. Having the fins, right, it can separate your air into like smaller portions, okay, and then equal space out, so they don't spin. The rocket will fly stably like that. If you have without this thing, the air will mix up and then they will start pushing your rocket everywhere. They don't fly straight. Now, if you say 3 also can, but 3 will be a lot harder to put. You need to perfectly space out like that, like that, like that. Also can, but notice, right, a lot harder for you to space out these spaces here. But then if you do 4, very easy one. This one opposite, you put 1 more. This one opposite, you put 1 more. Like that is perfectly spaced out. So it's better to put 4. No, you don't need to mention exactly how many pairs or how many. Just need to tell them you need to install fins for the stability so that they can fly straight. They can fly more stable. Okay? This is a water rocket. Of course, you put water inside, right? So water, the thing is what? This is not the real rocket. Actual rocket is that you put hydrogen inside, you put oxygen inside, they explode. So how do you have the similar effect? By having exhaust gas coming out, they put water inside. But the problem is water don't come out yourself one. Yes, they're not going to shoot out with high velocity. You want something to push it, right? That's why you put water inside, and then here you put air. After that, they put a tube inside. They pump the air here. They keep pumping to a point. Inside here, high pressure, they start pushing all the water out. And you cannot put too many water because why? You need space for the air to push the water out. So when you put 1/3 water, it will be the most optimum one because 2/3 will be air that pushes the water out and then they gush out, gush out, gush out. Okay, so this is why the 1/3 lah. You put 1/2 also can, but I prefer 1/3. Understand? So you see, how many points do I have already? 1, 2, 3, 4, 5. Okay. One thing I asked, some students ask also, can I put more points or not? A lot of people say, hey, can I put 6 points? Can I put 1 more point extra? Just in case, if let's say I got 1 big mistake, I still got 5 more correct, right or not? Now, actually in SPM, you are allowed to write more than 5 points. But listen carefully. Let me finish my whole sentence first. Okay, because the moment I say can, right, you start spelling. Now, you can add on a few more, 1 or 2, okay. But don't go crazy like, oh, can write more, then I put 10 points. If even I got 5 points wrong, I still got 5 points correct, I still getting full marks. Please don't do that. Okay? Let's say in your mind, I got other feature here, beside the fins. I can install other thing also. I can install a sharp cone here, whatever lah. You can write more, but add on 1 or 2 points enough. Don't go crazy. Next thing people say, okay, you know why I say don't spam, right? Because there will be something called wrong cancel right. You heard that before? WCR? Okay, but wrong cancel right is not what you think it is. Yes, a lot of people say, hey, is that wrong cancel right? Like, if I write wrong answer, my correct answer is cancel off. No, it's not like every time they cancel one. Only when you write contra answers. Okay, for example, here, the material density, what do you want? Just now, what do you say? The material is supposed to, okay, low density. Then later on, right, you say the material is supposed to be high density. High density, low density, opposite, right? Then obviously you don't know answer. You try to hantam. Hopefully 1 mark's correct, right? They don't work this way. If you hantam point like that, right? Here's the problem. The wrong answer, the high density is wrong. They will cancel off the low density. Okay, let's say you don't say density. Okay, you say that, oh, I need the material to be soft. Now, soft and density, any relationship. Soft material, any relationship with the mass of it. Is it heavier or lighter? It doesn't relate, right? So if your answer soft is wrong, they will not cancel off the density marks. So wrong cancel right, yes, it might happen, okay? But then, right, they don't happen so easily, only when you write contra answers. So I said you can write 1 or 2 points. Get it? But when you spam this wrong cancel right, will happen higher chance. And sometimes, right, a lot of people say, hey, I know this one, as long as I don't write opposite answers, I'm safe, right? A lot of times you thought your answer is not the same. You thought your answer is not opposite, but from your teacher point of view, it is. She's going to minus your mark. Understand what I mean, right? Okay, so how do we answer this? Now, first thing first, put them in table form. Okay, nope, this one you draw yourself on. Exam don't give. Title, right, they don't care. But normally, for design one, right, I just put design, because it's called design essay. I put design. If you don't want design, you can say modifications. Also can. But title doesn't matter, they don't minus 1. After that, over here, you put the reason. Reason. Explanations also can. Reason also can. Expect is for design. Later. Expect is for dissect. The other one, section B, then you write expect later. But then for design one, right, just write modifications or suggestion also can, but don't write expect. Can Alright, now I give you the answer, you can write down. But of course, you want to take a screenshot also can. Now, one look here first, before you copy anything, right? Material, no, I don't need, again, it's, even though it's called essay, but we just need short sentence, see? Material should be low density. Why? Put your reason inside, the rocket will be lightweight, able to travel faster. Okay, higher velocity, of course, can, right? Shape of the rocket should be aerodynamic. Why? To reduce air resistance acting on the rocket means they go faster. Angle of launching, 45. Now, of course, you don't have to say half, no. 45 degree, rocket able to travel maximum horizontal distance. Means furthest. You can say further distance also can. Volume should be 1/3. Why? Because the rocket will be lighter, the water will push out with higher velocity. Will be pushed out with higher velocity. Okay? And then one more thing, fin should be attached to the tail. Why? Rocket able to move smoothly and stably. They don't wobble, they don't swing around. Okay? Now come write down the answers. Okay? Last year midterm question came out, student asked answer plastic bottle for materials, teacher mark it correct. Then she wants to mark it correct. I'm telling you don't. Okay, I give you the correct answers. is that this is the supposedly to answer. Your teacher wants to accept plastic, of course plastic. Can I just put in low density? No. Short sentence, don't lazy. Okay, put them in sentence form. Don't write point form. Some teacher cannot accept point form one. Yes, I said many times already, I don't want point form. I want short sentence like that. Am I asking a lot? Just, I'm not even asking you to write like, karangan, right? I just want short sentence, so please give me a complete answers. Don't cut corners. It's exam. Exam also, you want to cut corners, then how? If I write material used should be strong, would it contra? No, it won't. It won't. Yes, acceptable. If you don't want to say density, you can say strong also. Then your answer, your reasoning will be so that the rocket does not break easily. Because you pump air inside. Inside the pressure very big one. So if it's soft, they will burst. Durable cannot. Strong can. Durable cannot. Now, one thing very important, do not write durable. Because durable is very bad answers. No, having more tails give you more mass. Does not mean more tail is better one. And I say already, I don't need to mention specifically how many tails. So just say have tails attached. Come, write down. Once you are done, right? You send me a rocket. Durable, don't write, okay? Because what do you mean by durable? Say, what do you mean by durable? It lasts very long, can last forever. But here's the thing, durable. Okay, if I say I have a bottle that's durable, what means about that? Can last long. And then how long is last long? Maybe for you, last 3 months is durable, but then maybe for me, last 3 years only durable. Realize, right? It's very subjective. Okay, and simple thing, when your answer create another questions, it's a bad answer. So the moment you tell me this answer and I ask you why, then you say, oh, this thing will be durable. Why durable? Or because it won't break. Then say it won't break. Isn't it better? It's more straightforward, right? So here's one thing, answer always right, straight to the point. The problem of all students is always that one. You like beating around the bush. No good. Straight to the point. Okay? When I answer, create another questions, it's a bad answers. Understood? Alright, I see our rockets ready. I assume you're done ready. Those who are not done yet, take your screenshots. No, because copy is not the problem. You need to understand what. You can take a screenshots later you slowly copy. And answer will be provided to you, even you really doesn't want to screenshot whatever thing. Right? Okay. Next one, let's try one more. Now I want the design punya essay. Everybody, can we look at page 17? 17. Page 17. Page 17, question 6. Question 6. This one. Alright, here, airplane moving in the air. Okay? Airplane move forward due to principle of conservation of momentum. Sorry, typo. 1 O only. State the principle of conservation momentum. Okay, this one I leave it to you. We did just now already. What the definitions we wrote just now? Total momentum always constant, always conserved if there is no external force acting on the systems. So I don't write I leave it to you. This one, structure of a jet engine. Now you know how this jet engine works. Now they kind of describe to you what. First thing first, have you seen before like airplane, jet engine? In front you have like it looks like a fan thingy. It's we call it propeller It's like a fan blade like that But here's the thing this thing don't blow air normally a fan blows air, right? This propeller is to suck air. Yes, they draw air inside. You know why or not? Again, why do you want air go inside? Now, when we go inside, what do we have here? This thing is called combustion chamber. What does it happen inside here? Combustion is correct. Combustion needs what? Yes, you need air to go inside, So why we draw air in? Because you want combustion to happen here. And again, combustion means what? You start burning. What do you produce? Hot gases, hot exhaust. Now, by the way, the word nozzle, you need to learn because you use it often. Rocket, jet engine, all use one. Nozzle is like the back part of your plane. I mean, not just only jet engine, rocket also. The part where the hot gases shoots out, the part where all your exhaust gas come out, It's called nozzle. Okay? So after combustions, exhaust gas come out from nozzle. Okay? Alright, explain working principle for the jet engine. I think you know what to do already, right? Use the format we did just now. What's the first thing we say? Whatever, whether rocket, whether jet engine. Can answer, right? What's that? Step 1 says what? Yes, tell them explosion occurs. Good. When air mix with fuel. Wait, when air mix with fuel in the combustion chamber, combustion starts, yes, and then most importantly says what? Correct. Explosion occurs and it produces hot exhaust gases. Second point, what's the next thing to say? After the gas produced already, what happened? The gas come out. Correct. How? The gas come out again? The hot exhaust gas how? Will exit the nozzle with high speed, correct? High velocity better. High velocity, producing a high momentum. Not good enough. Anyone can tell me what's missing? This sentence. What did I say? You must mention directions. Where is your gas going now? Is it still downward? No, right? What's that? Correct. So this one need to change. Instead of writing downward now, your exhaust gas come out from backward. And then third point. What's the third point we say? According to principle of conservations of momentum. What happened? What was it? No need. I mean, you want to write full also can one. Some people say, actually, can I write like full sentence, like full definitions? But you don't have to. You can just say the total momentum of the systems will always remain. Conserve also can. Constant also can. Therefore, finally, what do you say? The jet engine will move where? Forward with an equal but opposite momentum. Ta-da! You see? Do you start seeing it? You get the idea now, right? When you understand the format, things become simple. Every time they ask you to explain any explosion questions, answer, right? What's the key point that you must mention inside? Tell them it's explosion. And then high speed gives you high momentum. Must mention the directions. Tell them principle says what? Total momentum always conserve. Therefore, jet engine move forward with an equal but opposite momentum. Understood? Alright, let me know when you're done so I can move on to next type of essay now. Okay, right, this one. So if I ask you like, explain how a gun firing works, you should know what to do, right? I ask you explain how the squid works, you know how to answer, right? That's why, rather than memorizing it, try to see the common thing between. Then whatever they ask you, say, okay? Your internet unstable. Wait, am I lagging? You look at my head. Just now lag. Why? Is it because? Aiyo, laggy. Camera black. Wow. Let me see. What's wrong? I just heard this 10 seconds. Aiyo. Why? Is it because the... Okay, but okay or not so far? If let's say lag and you did not hear the answers, you let me know. Now you are lagging. Okay, now you are lagging. Wait, let me settle. Let me do something about it. Wait. Okay. Okay, any problems now? Am I lagging now? Is my head moving? No, just now like very normal because I switched Wi-Fi ma. Yeah, but right now, right, I mean, after this should be no problems right? Because just now I was switching from another Wi-Fi to Wi-Fi, so that moment confirm like one. Yes, but I think right now should be fine. Okay, I'm already No lah, now the speed very fast already. No problem. Yeah. If you know how lah, you can actually you can uh, you can actually control your Wi-Fi on. Because sometimes your Wi-Fi is shared by a lot of people in the house. Then they slow. You can choose which device to get more Wi-Fi, which one got less Wi-Fi. Okay. All right, let's move on. Settle. Okay, next one, jet engine. Yeah, but this part okay or not? Just now, did you miss out anything for this part? Okay. Good. All right, now next. Here, this is about the decide essay. Okay, this one is about your decide essay. How do you know you're dealing with decide or not? Now, this is the moment you see, they give you a table form, okay, and then they ask you to explain. So over here, what do you notice is that you have this so-called jet engine idea, one by one. So first thing first, you don't care this one first. They want this here. They want you to explain suitability and then determine the most suitable design. Choose the correct design. Now, which one is the best one? I give you 2 minutes, you decide. Which one do you think you should choose? You go, no, you don't have to answer anything first. Choose first and tell me what's the answer. Choose first and then tell me the answer. Let's see. First thing first, diameter for the nozzle. Do you want big or do you want small nozzle? Which one? Okay, nozzle is here. Nozzle is where the exhaust gas come out. So what do you want? Should you have a big nozzle or small nozzle? What do you think? Answer is you're supposed to have a small nozzle. Correct. Okay, I get it. People say, isn't it big? Because I want more exhaust gas come out, right? Okay, what did we keep writing here? You need the exhaust gas to come out from the nozzle, high speed, so that your momentum high, right? Exactly. And nozzle actually is basically the opening, right? So what happens if you make it smaller and bigger? The speed will change. Okay, a simple example. Later you can try literally. Do you have those like water pipe at home? Like the usually rubber tubing, the rubber hose, orange color one, right? Have you tried cover up half of the tube? You squeeze it like that. What happened to the water? If you cover half of the hole, what happened to the water that comes out? Suddenly they go crazy fast, like all the way, right? Right. Yeah, lor. So when you reduce the diameter, basically the same effect lah. when you reduce diameter, right, instead of having big diameter, now you make it smaller, what happens? All the gas they get pushed out and they must force out all the way. So that's why smaller diameter is actually better. You know why or not? Because they give you higher speed. Higher speed means what? Higher speed means you get higher momentum. Next one, propeller size. What do you want? Big or small? Propeller is here in front, no? And then what I told you, right? This thing is to draw air inside one, suck the air. This one, yes, bigger is better, lor. It's like your fan. When it's bigger, they give you stronger wind, right? Bigger, they attract more. Type of the fuel. Airplane, use what kind of fuel or not? Paraffin, liquid hydrogen, kerosene. Yes. Oh, but I want to say one thing. This one should be a typo though. Yeah, this one should be a typo. Kerosene should spell this way, what? Isn't it? Right. If I'm not mistaken. Or both are accepted. Okay, never mind. You have me to change. I want this. Kerosene is supposed to spell this way. S-E-N-E. Have you learned this before in chemistry? Or maybe last time in science? Kerosene is well known to be like the fuel for the jet engine. For airplane, basically. Paraffin can use also, but we don't really use paraffin too much. Usually it's kerosene. This one? Anyone can tell me? Actually, liquid hydrogen for what? What was the function for liquid hydrogen? No. Cooling, that one is liquid nitrogen. Liquid hydrogen is fuel. Yes, liquid hydrogen is the fuel for rocket. You know what happens if you mix liquid hydrogen with liquid oxygen mixed together? Like liquid oxygen and hydrogen mixed together. They will go kaboom. Exactly, they explode. No, they don't become water. Hello. Water, H2O, hydrogen bugs. No, that one is you have to have the correct ratio. If you just mix them hydrogen, oxygen, right, they explode one. They don't become water, they're gonna explode. So for rocket, right, we use this. Of course, you ask, then isn't it better if I use hydrogen for my airplane? My plane gonna explode and then fly very fast, all right? Like a rocket, all right? Now, rocket different, you see. Why do you want the explosion? Is because you want the rocket to become high speed. Because you want to escape the gravity. You need to fly out of space, you have to go very fast one. But for airplane, it's more towards like to last long. Because you want to fly from one country to another country, it takes hours. So if you do liquid hydrogen, what's the problem? They will actually finish up very fast, and then your airplane fly halfway, no fuel, they fall down. So usually we use kerosene, they last longer compared to hydrogen. Hydrogen too reactive already. Your engine will spoil fast, no good. Okay? And then people inside cannot the person inside cannot take it run too fast, cannot take it. Okay. Size of combustion chamber, 3 marks. Of course, you want bigger combustions, better. Okay. So final answer is supposed to be L. Now, this is when the mistake comes. Tell you what, normally for the side essay, very simple one. Everybody sure no answers one because you surely got this one guy perfect. And you got all you surely get this one guy, right? You get all the good thing one. Okay? But then this is when the problem comes. Why do I say so? Listen carefully, guys. Here, you read the questions. What is the instructions here? They want you to explain suitability for each aspect and then determine the most suitable design. Yes. So what is when do you tell them the most suitable design is L? Last sentence. Okay, you tell them L is the best. That's conclusion. Now, simple idea. When you're doing report for science report, when you're doing experiment, where do you write the conclusions? Where do you write conclusions? Do you write the conclusions in front or at the back? You start the first line. The experiment will be like this. Then only you do a procedure. No, right? The last one, right? Same thing here. Conclusions are put at the last. That's why you look at this table, a bit different one. Do you realize this table, right? I mean, this one I draw for you. The last row, it's like one column one. I never separate them one, right? Now, this one very important. Every time, especially first exam midterm, right? This is the thing that you're gonna. Because you know what they do or not? A lot of students, they will start by telling me, L is the best. Because L has small diameter. L has big propeller. L uses kerosene. L is big size of combustion chamber. When you write this way, 0 marks you get. Now, All your answer is correct, but you get 0. That's why one thing very important here, the format you must follow. Listen, how to do right. First thing, ignore here. You do not care what you write here at all. Okay? Don't care first. Just tell them in your mind what's your ideal, what's your best jet engine. You get me right? So one by one. So first thing first, title. This one you write expect, because this one is basically the side essay. Expect. If not, you want to say choice also can. Then this part also same thing. Reason, explanation, all can. Now first thing first, what do you say? Now, you don't tell them what is best first. You tell them in your mind, the best propeller is supposed to be how? Diameter of the nozzle should be smaller. That's it. Short sentence. I don't need like very long answers also, right? Yes, essay, regardless, section B, section C, all table form. All table form. That's why format very important. But if I don't tell, you won't know. You start writing paragraph, your marks is gone. Now, why do we want nozzle smaller? Just now we said already. Why do you want the nozzle smaller? Yep. You want the speed to be faster. Okay, wait. I give you full answers. Hold on. Wait. Hold on. I need to type out the answer first, and then I'll show you one shot, so you can see the whole picture how. Okay, here. What was the first thing we said? Number one, what do you say? You want the diameter of the nozzle to be smaller, right? What's that for? Exhaust gas or exit nozzle with higher speed. And then remember the dimensions of? Higher velocity means you get higher momentum. You can always explain more. Okay, here's one thing, guys. You can always explain more. When I say explain more means that, you can put more details inside and everything. But then one simple idea is that you're not supposed to put two different answers. Some people say, can I put different reasons so hopefully one of my reasons is correct? You cannot tembak like that one. You can say, I want higher velocity, and why is that so? Further explanations, higher velocity, higher momentum. That's all right. But you cannot say, so that the exhaust gas high speed, and then so that the exhaust gas slow speed, so that exhaust gas higher temperature. No. When you write two different points, cannot. You need to continue writing. Get it? Next one. Size of propeller supposed to be larger, right? Why do you want big propeller? Just now I said, right? Propeller is to draw air inside. So if it's bigger means what? No, don't use the word suck more air. What's the better word to use? Draw. So able to draw more air into combustion chamber, and then better combustions. More combustion also can. Okay, because more oxygen. Okay. Next one. Parafuel. Type of fuel. Why do we use kerosene? What's the reason of using kerosene? Kerosene has higher level of combustions. Yeah. Now finally, size of combustion chamber. Bigger. Why? Bigger combustion chamber means you get more combustions happens at the same time. It produces more exhaust gas. Okay, right now, stop. Everybody look here. Final sentence, how to write. Okay, look here. What's your choice? Which one do you choose? Design of the jet engine. Which one do you choose? L, right? Okay, look your final answer, how do you write, right? Here. First, you tell them, therefore, most suitable jet engine, L. Okay, then you full stop. Next sentence, you just recopy whatever you say is good here. What does it mean by that? Now you tell them, because jet engine L has small diameter for nozzle, large size for propeller, uses kerosene as fuel, and then the size chamber is big. And yes, literally, you recopy everything. Now, how the marks was given. Pay attention first before copy. Look here first. You listen first. If not, you're going to ask me same questions one. Just now, right, how was the marks given to your design essay? 5 marks, 5 points times 2, right? Now, this one, you choose one by one. All this thing, explain one by one. Diameter small, you explain correctly, right? 1 point here, explain 1 mark. Okay, choose correctly, explain. Choose correctly, explain. Choose correctly, explain. So the entire table, how many points you have here actually? You only have 4, right? So each one of them you get 2 marks, 2 mark, 2 mark, 2 mark. Now, if you sum them up together, how many marks you get now? You only got 8, right? Now, what happened to the other 2 more marks? You choose the correct jet engine, they give 1 more mark, and then you recopy all the advantage you set up here, they give you 1 more mark. So they practically giving marks for recopying. So 8 marks plus your final conclusion 2 marks, and then sum together, 10. Only the side essay, you need to put conclusions. I mean, design, why do you need conclusions? Design is all your answer, ma. What? Your final answer say, therefore my design is the best. No, right? This one is because you're choosy. That's why you must have conclusions. So that's why the format a bit different. No? That's why I say 8 plus 2. You get me now, right? The side essay, 4 points, 8 marks. Conclusion, 2 marks. Together, 10. Design, 5 points, multiply 2, 10 marks. Understand? Okay, now come, write this down. Once you're done, right, you send me an airplane. I want this. I need to go toilet. Come back real quick. Finish up, let me know. Okay, I'm back. Hello. Hello. Are you done? Hey, you need to respond, you know. If not, I don't know whether I'm lagging or you just never respond. Yes. So later I ask you a question, please answer me. I scared. Because you all tell me I keep lagging. Still got lag or not? Not supposed to lag anymore already. Because I already changed the Wi-Fi setting. No more lagging. Yes, because I literally dragged all the Wi-Fi to my computer. Right now my Wi-Fi is 480 megabyte per second. Confirm got enough one. Alright, next. Continue. Good. Can I move on some more? Try again. Okay, I want to do some impulsive force and impulse questions. Page 12. Oh, why do you send me a screenshot of my answer? Okay, page 12, everybody. Question 4. This one. Watermelon. I try to copy the emoji. Diagram 4. Watermelon falling from a 2.5 meter tall building, about the building table, dropping on the floor surface. Watermelon, 1.5 kg, experience a change in momentum after falling. While falling, sorry. First, what is meant by free fall? Now, I say already one definitions, you want to memorize or not, your choice. Confirm ask one. In fact, every time, right, the first questions is always like, they like starting off asking you definition. That's why you will have this feeling one, like, The whole paper was asking about definitions. It's 1 mark. Definition is always 1 mark. Okay, free fall. What is that? Falling under gravitational force, not correct. No, okay, free fall means only gravity. Yes, yes. No air resistance, no air frictions, right? Okay, so what's the meaning of free fall? Object falling under effect of gravity only. Okay, that's it. You don't have to say what gravitational force, whatever. Just tell them straight away. Falling, and then you say only already, ma. So no need to say no air friction, whatever. Object falling effect of under effect of gravity only. Yeah. Next one. Calculate the time taken for the watermelon to reach the floor. Now from here, pew all the way down. They want the time. How? What do you think? That time I wrote gravity only. Teacher gave me wrong. Then what you supposed to write? Huh? That's literally what's written in the textbook. Okay, if the teacher wanted gravitational force, then you write gravitational force. Sometimes it's like that. They have their own insist lah. Then you follow. Okay, calculate time taken for the watermelon to reach the floor. Okay, what are we doing? What are we doing? First thing, of course, all the time, all the suvat, right? Correct. Anytime lah, whenever they ask for time, they ask for distance, displacement, travel, right? All this suvat long, SUVAT, right? Now, one by one, we fill out first. They're asking for time. What is provided to you? Not too many things given, right? If they don't give the suvat formulas, you are screwed. Yes. Ask your teacher whether given or not. I really don't know. You ask the teacher. Okay. 2.5 meter tall. Of course, S is 2.5. What else? Given to you. U is initial velocity. How much? Initially, you see for yourself. Nah, here. Is it moving? Yep. 0. Oh, okay, guys. Not every time your U 0 one. Okay, I want to say this. Not every time 0 one. Because yes, a lot of time when you're doing questions, right, you get 0. Then you start feeling like, oh, does it mean all initial must be 0? Now, I will suggest, I will tell you one thing. How do I know this is 0? Because it's on the table. That's why 0. And then one more thing I can teach also. Every time we got all this falling one, okay, vertical motions, up and down motions, right? You look for words like that. Okay, I tell you, normally, right, you got few words to pay attention to. Now, if they say drop, or they use the word released. Now, drop and release, right, it's like just let go. You don't apply any force one. You don't apply any force one. Okay? Now, if they say throw means you're gonna use force one. You're gonna apply force, and then they're gonna leave your hand with a speed. Correct. So when you see the word throw, drop or released, then initial velocity will be 0. But if you see the word throw, then initial velocity will not be 0. Yes. And yes, you can understand the same this way also. If your U is not 0, they must tell you. Yes. I mean, of course, you say, if it's not 0, then how much? They must tell. Takkan they say, oh, you guessed? No, right? So if it's not 0, they will tell you. Since it's not being told, then we assume 0 lah. Now, what about V? Okay, I get it. People tell me V is 0 also. Because they say, hey, like that, pop, crack, break, isn't it 0? Now, listen, actually it's like this one. Every time when we drop something, okay, from here is 0, right or not? And then as you fall, what happened? You tell me first. Normally, when something falling due to gravity only, what's going to happen to the speed of the object? What happened to the speed of this watermelon? As they fall, they're going to be faster, faster, faster. Accelerate, accelerate, accelerate. Now, actually, right, every time when we say final velocity, what does it mean, right? You see, watermelon here, just before you touch the ground. Like, you just imagine like 1 mm before you touch the ground. Now, at this moment, we call this as final velocity. Okay? Then, of course, finally, when you land, pop, stop. But the final we refer to, it's here. So, not going to be 0. Not going to be 0. Understand? And it's a very simple reason. You think about it yourself. If your U is 0, your V is 0, what will happen? When you have so many 0 in your calculations, what's going to happen? 0 equals to 0 plus 0. 0 equals to 0 times 0. 0, right? Exactly. You cannot have many, many 0 in that one. And here's one simple trick for you to understand yourself also lah. When you realize you got a lot of 0 in your calculations, something is wrong. Then you double check. Okay, so this one, I cross it up. No, not 0. But they never told you, right? They didn't say anything, we cross it up. I don't have it. Okay, next one, what about A? They never tell A also, but this one, you need to know yourself. You know why? Because they hint you already. This thing falling, when you fall, what is the reason? Gravity. And what is the value for gravity? The standard number we get always? Correct, 9.81. 9.81 what? This is gravitational accelerations, you know, the little g, the small g that we always talk about. There you go. Okay. And of course, you start asking me, hey, what about the negative? When should I put negative? When should I put positive? Now, simple. Physics every time. What does it mean by negative? Negative means opposite, good. Right now, you tell me, this watermelon going what directions? Down. Gravity going what directions? Down. Do you see any opposite directions there? Then why do you want to put negative? Right? We only put negative if they're opposite. Right now, if you throw this watermelon up, gravity down. Right now you tell me this is negative 9.1. You are correct. And I understand. Some teacher will tell you that I don't care. Every time you put negative. You know what or not? Okay, listen. Let's say for these questions, your teacher insisted, she said, I don't care. You must put negative for your gravity every time. Okay, so you are saying that going down is negative 9.1. And you know what happened? If you put a negative here, the value for S, the displacement, the 2.5 meter, you need to put negative also. Because this is going down. So if you say going down is negative, anything going down, negative, then is it like one more steps extra? Because negative and negative will cancel off. Then you might as well at the beginning don't put inside. You understand what I mean, right? So if you only got one directions, both object, gravity going down, positive only. No need plus minus one. If the object goes up, gravity goes down, then that is when the negative comes in. Understand? Okay, regarding Subat formulas, of course, nobody remember one, right? Here, I give you already. See? Over here, linear motion equations, we always got 4 formulas, right? Yes, and you know why is it called Subat, right? Because the formulas are basically formed by these 5 letters always, S-U-V-A-T, right? But the thing is what? Every time, right, the formulas how? There's always one guy missing, right or not? Yes, we call them Subat, but did we actually use all 5 every time? We didn't. You look at the formulas, what do you notice? You probably will notice one simple thing is that every formulas, right, always one guy missing, right? Now, what's the guy that missing for the first formula? You look at the formulas and tell me, what's missing for first formulas? Without A, correct. You just read out and you can tell S-U-V-A-T. This one here, what's missing, number 2? S-U-V-A-T. Yep, no final velocity. This one here, what's missing? S-U-V-A-T, no S. And then the last one, S-U-V-A-T, no T. So, you know, why do we do this every single time? Because when you list them down, you know which formula to choose. And you choose your formula based on whatever is not provided. I got no final. I don't want my final velocity inside because I got no number. Which formula do we choose, guys? 1, 2, 3, 4. Which formula do we choose? Yes. Which one? Number 2, correct. Because you got no final, So you choose the formula with no final inside. You don't have to calculate them. Understand? Yeah. So S equals to UT plus 1 over 2 AT squared. I say this again. I don't know. Formula sheets got give or not. You need to ask your teacher. But if formula sheet is provided, this will be inside. Okay. But the problem is you need to ask is there a formula sheet? That's the thing. Okay. U multiply T 0 plus 1 over 2. A it's 9.81 and then T is what you're looking for. But don't forget there's a square there. So 2.5 equals to 4.905 T squared. Now what's the final answer for T? Bring it over, divide. But don't forget there's a square root there, right? So square root 2.5 over 4.905. Remember bracket or if not your calculator very dumb one or. They thought that you want to square root 2.5 first and then only divide 4.9. A different story. You want to divide the whole thing inside. And yes, I need answer from you. What do you get? Please calculate for me. Final answer. Yes, everybody. how you find A? Oh, A is gravity value, standard number. You need to know yourself one. My physics teacher said I have to make the 9.1 negative all the time because direction towards the ground. That's the thing, lor. So if your teacher insisted lah, you need to put negative. The problem is, you know what happened on all these questions? You have to put negative 2.5. Because here negative, they cancel off. Which is more troublesome. For what? Right? Why do I put negative on both sides? Just to cancel them off. Which I definitely gonna get same answers with without the negative sign, right? Oh yes, decimal point. Okay, just in case every time you do calculations, if there are endless decimal point, always leave them in 3 decimal point. 2 is too little. 2 is too little. I would suggest put 3. Okay, 0.714. 2 is too round off. 4. Put 3. Put 3. 4 is too much. 2 is too little. Put 3. Okay. Next one. Calculate velocity of the watermelon just before hitting the ground. I know you know to. I guess you know what to do, right? What are we calculating? What's that? I just only say, right? What's this velocity just before hitting the ground? Yes, that's your final velocity. So what can we do? Same suvat, bring down here. But then now what we do? Instead of cancel off, now you see, final I put a cross. Final I put a question mark because they want you to calculate. And then time taken I cross out. Of course, you can put the time here that you found inside, but it's your own answer, so there will be a risk there. So usually, I'm not saying you cannot, but if you could, try to not use your own answers. If this is wrong, you bring down wrong. But you see right now, I'm not using my own answers. So even this is wrong, I will still get correct answers here. Get it? And yes, what formula do we use? You should know how to choose already, what? Which one? 1, 2, 3, 4. Which formulas? I got no time. Correct. 4. So V square equals to U square plus 2AS. Okay, substitute again answers. U square plus 2AS. Okay. V square is what you're looking for. U square 0 square plus 2. A is 9.81 and then S is 2.5. V square equals to 2 times 9.81 times 2.5. We get 49.05, is it? So V, remember, square root answers. So what's your final answer for V? 7.004. Because I think you get 0.0035, right? So the 35 you have to round off. So 004. Unit, guys. Velocity. Now, reminder, every time you do any calculations, put SI unit always. Okay? Can I substitute 0.014? Of course can. You probably get the same answers anyway. So if your answer is correct up here, you substitute this in, of course can. But my suggestion is try not to. If this is wrong, then how? Second problem is what? Is your time really 0.714? It was a round off answers, am I right? So your final answer will be a bit off. Let's say the answer is 7.004. If you use a round off answer, substitute, round off again, you will end up having like 7.003, 7.002, a bit off one, the last digits. So this is why I say try not to use all answers. Not to say cannot lah. Just try not to. Because sometimes you got no choice one. You have to use your own answers, then go ahead lah. So again, I'm not saying that you must not use your own answers. Try your best not to use it. Okay? It reduces a lot of careless mistake on you, trust me. Next one. Watermelon hits the floor, break upon landing. What's the change in momentum of the watermelon when it hits the floor? Anybody can tell me actually what is this so-called change in momentum? We have a term for this. A word that describes change in momentum. I mean, change in momentum is the definition for this. Correct. Change in momentum actually is impulse. Like literally, definition for impulse. Change in momentum. Correct. How do you calculate impulse? How do you calculate change in momentum? Okay, let's just say you don't know lah. Let's just say that you don't know that change in momentum is impulse. You can still calculate them what? Okay, what does it mean by change in momentum? Okay, how about this word? What's the meaning of the word changed? Okay, let's say initially let's say for me I am 100 kg. Okay, and then I decided to cut down. And then my mass now is 70 kg. What is my change in mass? How do you get the 30 kg? You minus, right? So what's the meaning of changed? Change means difference. Okay, so when I say change in momentum, first thing first, how do we calculate momentum? Mass multiply velocity, right? So how do you calculate change in momentum? Mass multiply velocity minus mass multiply velocity. Okay, final momentum minus initial momentum. Now, mass of watermelon easy lah, given to you already, 1.5 kg. Okay, all given one. Okay, now what about V? What's the final velocity of the for the watermelon? This one a bit tricky. Every time you're gonna, the final here should be 0. Let me explain first. You copy first. Okay, now, and then the initial velocity 7.004. You calculate first. Never mind, you calculate first. I know what you want to ask. You calculate first. This one 0 lah. 0 minus the answer, you get negative. What do you get? Final. Negative what? 10.506. What's the unit for change in momentum? Minus, don't change unit one. So you are still having momentum, minus momentum. kg, ms, negative 1. Okay? Alright, now of course you ask, hey, just now I thought final was 7.004 and then initial is 0. How come here we swap places one? Because we are looking at a different story. Look, for the suvat here, what is the process? This is the ground. The watermelon, they want you to calculate the time taken for watermelon to reach the floor, right? Basically means like this, you see. This is the watermelon. Hey, what happened? Okay, this is the watermelon, and then it falls all the way. And then what did I say? As it falls, it gets faster and faster and faster from here. And then what happened? The final is actually referred to what? The velocity just before you touch the ground. Okay, so here would be initial, and then just before you touch the ground, here will be final. Okay, for suvat, it's like that. Agree? Initial, final, time taken. Agree? But right now, you read the questions again for number 3. What it says? The watermelon hits the floor, breaks upon landing. Now, I ask you a question, where do you get impulsive force? During this falling process, right, is there any impulsive force happening? Think about it. It's like, let's say you jump down from tall places. When do you feel pain? When will you feel the pain? Yeah, no? Do you feel any pain here? No, right? Now listen, everybody. Impulsive force only happens when you collide. The moment, you see, here, land, this tiny bit of moment is where you have the impulsive force. Here, any impulsive force? No. And some more they mentioned very specifically, hit the floor, breaks upon impact. That's why the final you're looking at now is here. The moment they landed, okay, and then breaks. So for the impulse point of view, this would be your final. Whereas, right, just before you touching, right, now it will become the so-called initial. This is the one thing that people always confuse a bit on. When we're doing suvat, I start from here, I go down all the way until here. So this is my initial, and this is my final. But then when we're doing impulse, when we're doing impulsive force, it lands and stop. So here become the initial, here become final. So right now, what happened there? It was the final just now, it will become the initial value. And then when you land, it breaks, means what? Your final becomes 0. So now they terbalik. So the tricky part is that suvat is this part. Impulsive force is the part. Different part. So this one a bit scary, so we have to pay more attention to it. We good? Clear? Move on some more. Okay or not? Next one. No, we're not done yet. Some more. Take the correct statements about the impact time. What do you think? The impact time is supposed to be long or short? Your watermelon lands on the ground, right? Lands on this floor, right? The floor is hard or softened? What do you think? The floor is hard or softened? Hard. So means the time is supposed to be exactly shorter. And what happened? Why is the watermelon broken when hitting the floor surface? Very easy reason. Why it breaks? Because the floor is hard. Why the floor hard? Then it breaks. Because the time is short, correct. And then why the time short? It breaks. You see or not? We keep asking why, and then we get down to the bottom of answers, right? Reason very simple, right? When you impact, what do you get? Impulsive force, good. Now, impulsive force formula is what? How do you calculate impulsive force? mv minus mu divided by time taken, good. So, hard surface gives you what? Short time. Short time means what? Impulsive force high. Impulsive force high means what? The watermelon going to smash and break. Get it? That's a simple trick here. Yeah. Now I wanted to do one more questions. So, one more essay. I want you to get used of the essay. I explained all the detail about essay already, but I want you to try more. Then you can see the idea of how to answer essay questions. There you go. Write this down, please. I know, 4 o'clock already, but then the more I do with you, the less you have to study yourself. Okay? So, floor is hard surface. Time of impact decreases. Large change in momentum within short time of impact causes impulsive force to increase and break. Okay? No. Why do we say large change in momentum? Because the top part here never change one. Up here, memang big, because you're falling so fast and then you stop straight away, or from like velocity of 7 meters per second becomes 0. Then we just say large change in momentum. But most important point is focus here. The surface giving you short time, that's why the impact. So if you land on something soft, the time going to be long and then your impulsive force will be lesser. Okay? And yes, let me know when you're done. I want to do one more essay questions. Could there be essay for inertia? Yes, possible. Ask you design the oil tanker. The one they used to carry oil. Don't worry. Do what I give you here. I already thought it out. That's why I say, you trust me, finish this book, helps you a lot for your exam. Okay? Everything you need is in the book already. Do it. And somehow at the back, I prepare more like question chapter 1, chapter 2, chapter 3 or questions. Do. The more you do, the better at it, okay? I cannot guarantee come out for sure, but it will definitely help you. Okay? Can I move on? Settle? Alright, now let's talk about sports. Can you look at page number 15? 15. High jump. 15. Page 15. High jump. Now here, you're required to give suggestions for ensure safety and comfort of high jump. Contestants for modifications. Now here, what kind of questions we're dealing? What type of essay we're doing? Here. This one is design, correct? Because we got no table. Okay, good. So this one is going to be design, or you can say modifications. Suggestion also can. Okay, title not important to say already. Title can put Next one by one. Okay, then you see how many points give you. This one. Okay, sometimes they do like that. They hidden a bit. Is it really 4 points? You look at the points given to you again. Is it really 4 points? Actually 5 what? Why? I ask you a question. Is size and thickness consider the same meaning? YOLO. Size is size, thickness is thickness, right? Oh, there you go. You got 2 points already, ma. Now, see 1 point here, 1 point here, and then you talk about the elasticity 1 point. You talk about the material 1 point. You talk about the attire 1 point. How many points we have? There you go, 5. Okay. Now, size. What do you want? Size as in like, you want the methods like this, or like this. Is it bigger or smaller? Better? Of course, bigger, right? Why? How come you want it to be bigger? If it's small, what is the problem? If it's small, what is the problem? What happened when you jump and land? And what happened when you jump and land and miss? There you go, right? I remember I have this students told me before, like he did high jump and then land outside. Oh, Anson. Everybody Anson. Oh, so I assume you all like same school one now, right? Famous Anson. So Anson, I think you confirm get the answer correct lah. Exam hall, right? You experience it firsthand. Yes. If it's too small, you land here, then broken hand or right or not? So yes, bigger. Some more? What else? Okay, size bigger. What about thickness? What about thickness? Thick or thin? Of course thicker lah. Why thicker? More time to land, yes. And then the impact time will be longer. And then the force will be bigger. Good. Okay. Elasticity. Do you want your mattress to be okay? When you say high elasticity, it's like bouncy lah. If you say low elasticity, means they don't even compress. Like the floor is low elasticity. Of course, you want elasticity. Yeah, it's like a mattress lah. Is your mattress elastic? You jump on your mattress, what happens? Just fall comfortable and then nothing happens, right? That one is called elasticity. Yeah, so of course you want to have high elasticity because why? It allows your mattress to be compressed and then go back. Yeah, but if it's no elasticity, it lands, right? It's either you're going to make a big dent there and they don't go back to the shape. If not, they just go all the way hard. You land as if like landing on the hard surfaces. Again, broken arms, broken legs, right? So elastic must have, okay? Material for the bar, this thing. Now, again, when we say material, try not to say, I want this, I want that. No. What kind of material? Okay. What is the property that you need? Okay, you tell me it's a plastic, it's like a PVC pipe kind of texture. Okay, why do you want to use like plastic or PVC pipe? Light, correct. It's light. No, light is not the best answer. Correct. Flexible is. You want this to be flexible. Why? Because sometimes, okay, is it a must you surely jump over? Sometimes, you know what happens if you don't jump over? This thing will trip and fall. And then if this thing land first, and then you land on top, you know what happened or not? You're going to have a broken spine if it's hard. So what's the good thing about being flexible? They can bend, and then it won't break. Okay, so this is why we always do like a plastic, like a, the water pipe kind of texture, can bend one. But then just now in the morning class, right, got people tell me that his school used wood one. This thing, wood, like wood, kayu. Got anyone of the school uses wood? Wood very dangerous there. Yeah, because you land, it's hard. They use broom. What do you mean? No budget. My God. Oh my God. This one you want to be careful of it. Very, very, very dangerous. Not supposed to lah. Next one. Attire. What kind of clothing do we now actually you think about all the track and field kind of competitions, like you're running for 100 meters sprinting also, you want to go very fast one. Yes. And then you notice all the clothing, how they wear one. It's always very tight one, right? Why do you want them to be tight actually? Do you see people wear like a hoodie to run one? It traps air. Yes. So why do you want tight clothing? Because the air can flow through and then you do not have any air resistance. Then can go faster. Aerodynamic, no lah. The tight, okay, your clothes tight does not make you aerodynamic, but it will reduce air frictions. And then also, beside tight, one more thing. Together one, they actually, your clothing should, beside tight, one more thing. Now you think about all the sports attire, realize they uses one material now. They don't use cotton one. All your sports clothing, they use like polyester, like a nylon kind of thing. That thing is not breathable. Yes, lightweight. Again, you try wearing a hoodie to run, very heavy, right? So you want them to be tight and light. Get it? So when you put them together, here's the answer. Yeah. Look here first. Size larger. Why? You got larger landing area. Avoid athletes from falling out. Yeah. Thickness thicker. Why? Increased time of impact, reduce impulsive force acting on the athletes. High elasticity, so that you got more collision time when you land. Okay, guys, listen here. Stop copying. Look here. Do you feel like these two answers kind of similar? Yes. Probably people ask, hey, can I say can we actually say the same reason? Nah, listen in SPM, right, you are allowed to repeat answer twice. The third time, they minus your mark. Okay, 2 times, no problem. Like exactly same also can. Literally, you copy this and paste here. Can, no problem. But the third time, they will minus your mark. But actually, in SPM, right, they are very lenient. They're very kind to you. And so, as long as you rephrase your sentence, right, write them differently, they don't consider you repeating. Okay? So, agak-agak lah. Change a bit lah. Now, next one, material for the bar. You write either one enough. Either you say low density, either you say flexible. But your reasoning different. No? If you say low density, then you can say the bar is lighter, lightweight. If you say flexible, so that the bar can bend easily, does not break when it bends. Okay? And then finally, attire, tight and light. Because why do you want the tight? Reduce air resistance. Why do you want the light? And increase the accelerations of the athletes. Because simple, remember formula F equals ma. Lightweight means you have more accelerations, then you go faster. Get it? There you go. This is your full answers. Questions so far? Come, write this down. Let me know when you're done. The flexible and low density is considered as 2 points. Yes, 2 different points. That's why I said write one enough. So either you write the low density or you write the flexible. Either one. But to be honest, I will suggest write this is better. Flexible is more important actually. Low density is still okay. I will say this is better. But this is accepted also. Write one enough. Run enough. Okay. Let me know when you're done. I got one last part to mention. We're not done yet. A little bit more. I know. A little bit more. Let me finish this. I want to finish up soon. Yeah, I get it. I know. Okay or not? Done or not? Hello? Not yet. Hello? Hello? Can I move on? Can I move on? Good. Okay. Now you go to page 22. 22. This one I want to clarify. Right, this one I want to mention. Okay. Now this one, right, it's actually questions that ask you to choose which one is the best motorcycle. Okay. Now, the one thing I want to mention is no, we're not doing these questions. I just want to talk about this one here. Okay. Now, so over here, there's a column where they give numbers. Okay. And then here got 600cc, 250cc, right? Okay. You know what's with this capacity of engine? Simple. It's like the power. The bigger the cc, the faster it is. Okay. You ask your father. The car. Now, some car is like 1.5 cc. I mean, 1005 cc. Some car is like 2000 cc. Some car is like 2005. Now, the bigger the cc, the faster the car. I mean, the stronger the engine in a way. Okay. Now, so if you want a motorcycle that's fast, do you choose 600 or do you choose 250? No, it's not because more fuel. It's basically the power. Okay. All right. So 600. But listen, listen very important now. Now, for the site essay, right? Every time when they give number, never write the number. Okay? Very important now. Because you know why or not? Because this one you sure gonna one for this exam. Because they will give you like density, then give you number one. 300, 500, 600. Now, never write the number. Unless the number is very important, which very unlikely happen one. In the future, I tell you when. Okay, but right now, if your exam is only chapter 2 coming out, don't. Because why? Now, here's one thing. Why do I say never write number? Because one simple thing, is must I choose 600? Let me ask you a question. If I have another engine that is 800cc, is it better than 600? If I have another engine that's 1000, is it better? And then if I have another engine that's 1005, is it better? So you realize, right? You didn't want 600. You wanted more. Am I right? So next time when you get numbers, the site essay, they put number inside, right? Just use word to describe. The capacity of the engine should be higher. Okay? The density should be higher. Density should be lower. Understand what I mean, right? This one very important because every time gonna one. Okay? So this one here, don't write number unless the number is very important. Means cannot be higher, cannot be lower. Must be this number one. Then you say, I want this number. But this kind of questions seldom come on. Normally, in chapter 3 got from 4, chapter 3. The last subtopic, the satellite one, possible. But if you say chapter 2, right? No. Okay? So, one thing, I'm sorry, in fact, 2 things that I need to remind you. Number 1, when you're doing the site essay, okay? When they give you number, don't say, I want 600, I want 500, whatever. Never write the number. Say higher, say lower. Now, second, remember just now I said material. I said don't write the name, right? Okay, but listen, for the site essay, right, you copy from table. So let's say for I see whether I can find one for you or not. Hold on. 1 second. Okay. Like, you know this one here? The type of the field. Do you realize we actually write exactly the type? We didn't talk about the characteristics. Okay, that's the difference. That's why it's different essay. That's why you must understand the format lah. See, when they say different type of field, what happen? Now, if for the side essay, if they give, you copy. You just copy. That's why here we actually write the name one. But let's say for design essay that they ask for material, whatever, you just describe the characteristics. Means you don't say I want copper, I want aluminium, I want whatever thing. You say I want something stronger, something low density, something flexible. You see how's that different, right? So for design essay that you write yourself, material, just describe characteristics. For design essay, when whatever they give you, just copy, but never copy the number. Understand? Okay? Decide, you just copy whatever they give. They like for this one here, you just copy, say I want kerosene, no problems, because decide you choose based on table right? They give you answers, right? Then you choose. But then if they give number, just use word. Don't say I want 600, 500, 400. So for decide one, a bit tricky here. That's why you have to pay attention to. Understand? All good? Clear? Yeah? Any problems? So this one here, what you're supposed to choose? 600. But don't say 600, says what? Larger capacity of engine. One more thing. This one, shape. What do you choose? I just only say one. Aerodynamic, correct. Now, one thing, you're probably wondering, right? What's this? You heard of aerofoil before? Have you heard of aerofoil before? No, right? Never heard of it, then don't choose that. Exactly. Aerofoil is for airplane one. You learn this in Form 5, Chapter 2. Means this is not in your syllabus yet. Got it? Okay. The rest I leave it to you. Okay, answer will be posted as soon as possible. The video I try to post, the recorded video I try to post earlier, but then I cannot promise exactly what time because it takes time to process and then upload take time also. But I try to upload as soon as possible. Okay, is there any questions you'd like to ask? If not, then this is all I need you to understand. Now, for those who are having exam on 8th of April, all the best for exam. Please study very hard. Okay. All right. That is all I need to mention today, and I will see you hopefully. Okay. All right. Bye bye. All the best for exam.